So the M1 paper, international paper, October 2016, question 8, it's an inclined planes question with a pulley. So I've got two particles, P and Q, masses 2 and 3 kilograms. Lightning extensible string, goes over a smooth pulley, planes inclined at the horizontal angle alpha, tan alpha 3/4. Initially P is at rest on the inclined plane with part string, line great slope. Particle P hangs freely below the pulley, 0.5 meters above the ground. Coefficient of friction is mu. System is released from rest, and Q strikes the ground before P reaches the pulley. Q falls down, hits the ground, and when it strikes the ground, it's going at 1.4 meters per second. We've got to find out the tension of the string and the value of mu. Right, to start off with is the forces acting on P. I'll draw the forces first. So we've got the weight acting down on P, the normal reaction from the slope. We've got the friction going down the plane because it's trying to slow it down, and the tension's pulling it up. There's a 3G, the weight acting on Q, acting straight down, and the tension, of course. And these T's will be the same because it's a smooth pulley. P is going to accelerate up the plane, and Q is going to accelerate downwards. And we know the tan of alpha is 3/4. So the sine of alpha is 3/5, and the cos of alpha is equal to 4/5. You can get that by doing the sine of tan to the minus 1/3 on the calculator, or the cos of tan to the minus 1/3. Now we're going to use a SUVAT to find the acceleration. When we found the acceleration, we can find the tension using the equation of motion on Q. So we're not interested in the time. So it's the V squared is U squared plus 2ES. The V is the final velocity, 1.4 going down. The U is 0, so it goes from rest. The A is what we're trying to find, and the S is 0.5. 1.4 squared is 2 times A times 0.5, giving us that A is 1.96. So we know the acceleration now of A, so we can find out what the tension is. And just by looking at Q, the equation of motion 3G acting down minus the tension, which is pulling it back up, is equal to 3 times A. So the tension is going to be 3G minus 3A, and that gives me 23.5. 23.52 exactly, but write it to 3 significant figures because we're using G is 9.8. And then for P, if I look at the forces perpendicular to the slope, I can find out what the R is. The R is going to be equal to the component of the weight perpendicular to the slope, which is 2G cos alpha. If I put cos alpha is 4.4 over 5 in, and the G is 9.8, I get 15.68. Looking the forces parallel to the slope, it's accelerating, so doing an equation of motion, F equals ma. T is pulling it up the slope. The friction is slowing it down. The component of the weight, which is 2G, that angle's 90 minus alpha, so I'm going to do cos of 90 minus alpha, which is the same as the sine of alpha. So that component is 2G sine alpha, and that's going to be equal to 2 times A. It's going to be 2 times 1.96. So the friction then is going to be the tension, which is equal to 23.52. Then minus the 2G sine alpha, which is 1.2G, and then minus, we'll take the 2A over 2 times 1.96. So yeah, then the calculator should get 7.84. And the friction is equal to mu times R. So the mu is going to be the friction divided by the R, which is 7.84 divided by 15.68, which is half.